Hello, Keith Rucker here at VintageMachinery.org. Guys, today I am out in Colorado, taking a little trip out here and got a couple of little shop visits I'm going to be making over the next couple of days. But today I'm just outside of Denver and we're at a shop here that works on steam locomotive appliances. And I'm going to kind of tell a little bit about them, introduce you guys, and kind of tell me about your business here and what you do. And we're going to do a shop tour video and hopefully get to see some cool things. So, yeah.
Well, basically, we do all the locomotive appliances, from the air compressors to the dynamos to injectors, mechanical, hydrostatic lubricators, just about any appliance on a steam engine we've messed with or rebuilt or have drawings for, or parts that we can duplicate.
Good deal.
Yeah.
So, yeah, you don't think about, when you think about a steam locomotive in particular, there's lots of little accessories that are needed to make that run, and that's really what you guys specialize in.
Well, it's worked for 31 years for me.
There
so,
you go.
Hopefully for another 31. We'll see how that will work.
And the name of your business?
Backshop Enterprises.
And tell us names here real quick.
This is Reese Romine.
Yeah.
My chief machinist. I'm Bernie Watts. And you know Keith.
There we go. All right, well, we're going to do a little shop tour. So we're going to go around and see what we can get into and hopefully get some cool things for you guys to see.
All right, so this is our Lucas Machine Tool Co. boring mill. The number 41 precision, quotation, precision boring mill. And it's our main workhorse for any sort of big boring or big facing operation. We go through and bore with 14-inch cylinders all the way down to, well, the 6-inch high pressure ones on the cross compound air compressors, or we bore the 9.5 single stage, or pretty much any steam driven air compressor out there. We can probably bore it, and then once we get done boring it, we can go through and face it for the new gasket surfaces if those were leaking in the past, or they need to be cleaned up for our new gaskets. And then once we put the compressor together, we'll set it up on end, and we'll machine all the mounting feet to flat. So if you're mounting it on the side of your locomotive, they don't crack off if one is set too far back or anything. And I don't know exactly how old this machine is, but still
37.
1937, still runs like a top. It'll wrap it in any direction you want it to go. Wrap it the table this way and that way. The head will go up and down, and the spindle will go in and out. We do all of our boring using the table, and just lock the spindle in place, and that's how we do it.
So this is really cool. So I basically have the same size Lucas mill as this. Mine's older. You said this was 30 what? 1937. Mine was made in 1918, if I remember right. So about 20 years older than this one, but it's the same size boring mill as this one. So anyway, really cool to see this. And you got the big boring head on here. This is kind of neat. You just got one of the little carbide indexable pieces there where you can dial that in, move it up on a kind of a micrometer. You can control how far it moves.
Almost
in
a
and out.
vernier system too. I mean, we only dial in thousands, but if you wanted to, you can dial in tenths with that thing. But we can hold a thousandths on a 14-inch bore. No problem.
That is awesome. So very neat to see one of these in use and being used for boring. I haven't actually used mine for boring yet, so I got some jobs coming up to do that. Just got to get to them and find the time to do it. But pretty cool. Very neat. That's definitely a neat old machine.
So here's our Axelson lathe. It's 25-inch swing, 12-foot bed. It'll easily handle the 14-inch diameter pistons that we do on a regular basis for our cross compounds. And again, single stage at 9.5 or any pistons we need. It'll also turn all the shafts we do.
Yep. So it's a 25-inch swing, but it'll actually do 28 3/4 right over the bed right here, probably over the saddle. Get the 25 there.
Yeah. Massive tailstock that has actually a pretty ingenious little locking mechanism.
Oh, cool.
I
Yeah.
haven't seen that on smaller lathes, probably doesn't make sense, but you run along and it'll ratchet along, and you can lift up and lock the little ratchet thing. And when you really need it secure, you can lock down the two locks.
Yeah, I've seen that same ratcheting thing in some of the old Lodge and Shipley lathes. They did something very similar. Yeah.
And then when we need to, we'll pull the forklift out and bring the steady rest over and place it in front. But that's a rare occasion. We do short and round things more often than long and skinny.
Right. Very nice. These axles and lathes are really neat. I really like the little hand lever up on the top here where you engage the forward and reverse and all that. So, and what's going on here with the chuck? You got, is that
I assume that's an adapter plate. I haven't.
Okay.
I almost assume that this one may be a thread on chuck.
That's what it is. So he's got like a
almost
D16.
like a D8.
It's a D8. Okay.
I know D6 is smaller, so
Yeah.
I
So
can only assume D8 might be the
that
next
makes
size.
sense. So he's got a screw on chuck there. Okay. It works.
Yeah.
It works.
Yeah.
So cool. Yeah. Fire it up. Let's hear it run.
Quiet in the lower speeds, crank her up. She gets a little bit noisier. Yeah, this is also a brake, and it changes your direction if you go back up.
Yeah, that's a really nice feature. That brake and reversing mechanism built into these things. I really like that in the axles.
Less grinding gears, that's why I find this. Let it spin down and change it on its way down.
There you go.
That's as fast as low gear. Oh no, I'm sorry. It's almost as fast as low gear will do at 218.
And now we're up to 555.
No, we're still in 218 right
Oh, 218.
here.
Okay.
We can pop it over to high gear once it slows down. Let her sink.
There we go. Moving on.
Cast iron usually doesn't like to be run that fast, so we rarely get up there, but
Right. Could be on larger diameter stuff. Yeah.
exactly.
Yeah. Neat. So these old axles and lathes were definitely workhorse lathes, and I seem to see a lot of them in locomotive shops. So they were popular in the locomotive world. I know you said this one came from a former military, came off of
Out of the Rocky Mountain Arsenal.
Rocky
over
Mountain,
here in
Okay.
Denver. Yep.
World War II.
Surplus machinery. Yeah, World War II.
Yeah.
Yeah.
Pretty neat. Yeah, these are nice machines. That's a nice big heavy duty lathe. Cool. See what else you got.
All right.
Well, this power hammer here was the original, the one original machine from Westinghouse that I really need for this operation, because the piston is threaded on to the rod, which is sitting here vertically. And
So this is a piston out of an air compressor, right?
right,
Okay.
yeah,
So you got this flat disc, and that's where the rings go in there. It's very similar to a steam engine piston, not like a piston you'd have in a car. And you got the rod down here below it. So anyway, go ahead.
well, there's a boss on the end of the rod that would be hammered down into a relief in the piston. And then that locks the rod onto the piston so it can't come loose. Now that's the Westinghouse way of doing it. The New York air brake way of doing it was this forged rod, which we would need to have forgings to do today, or take it out of a solid bar, which would be very expensive.
Yeah, so it's got a flange on the end here. This is all one piece. And that flange had, what, the 3 holes in there?
Yep, and that's what bolts through the piston, through the flange, and holds the piston onto the rod.
But with this, they're just using the air hammer to basically just dimple that over, and that would keep it from
Dimple it
coming.
over. I mean, it's the strength is in the thread fit
Right.
between the piston.
It just
and the
keeps
rod.
it from unscrewing, basically.
It keeps it from unscrewing. Yeah.
Yeah. So let me show this again, so you can kind of see the little raised part there. So that hammer goes around and just kind of stamps that, and that will keep it. It'll kind of swage it in place and keep it from coming out. But they're using this little star bit on here. Was they got four pieces on it, and when you turn it on, this is kind of cool. You got this up here on the top, this belt, and
This one will spin it.
yeah, so that's turning that as it goes. So
And
it's
the rear one.
yeah, the hammer's going up and down. It's like a heave hammer, I guess is what you call it. It's got the little bar up on top. So kind of like a power hammer. Well, it is like a power hammer like a blacksmith would use, but this one
Right.
has been specifically designed for this function of, I'm going to call it swaging on a piston. That may not be the right term.
And it's been converted to a modern day, probably a 3-phase motor. But you said it came with a Westinghouse 2-phase.
Yeah.
Okay.
Which,
Nowadays it runs there, and it's got a slip clutch that's connected to this pedal. And push down on it, goes the town.
Wow. Very neat. And this is an original piece of machinery out of the Westinghouse factory.
out of the Westinghouse factory. Yeah. And as I say, it's the one piece that is essential as far as I'm concerned. Yeah, you can probably hand
Peen.
peen that over, or, use a rivet gun or something, but you're not going to get the kind of fit that we do. Once this is hammered over, there's a little bit of a boss that's left, and then we take it and put it in the axles and machine that off, and then we're ready to go.
Cool. That is definitely an artifact.
Well,
And
I thought that you and your viewers would get a kick out of that.
I can't read it. I think it said the High Speed Hammer Company. Yeah, the High Speed Hammer Company is who made it. Who they also made power hammers for blacksmithing and stuff too. So I think we may have some catalogs from them on our website. I'm gonna have to go see if that's in any of the old catalogs, whether that was something that was custom made for Westinghouse, because I can't imagine there was a huge demand for these things outside of that.
Well, we have different size dies to hold this thing. We don't have this in here tight now,
Yeah,
but for the different diameter of rods.
right.
And so it was made specifically, as far as I can tell, for Westinghouse.
And this is a used piston and rod set that we've done for viewing purposes. If
Yeah.
it were new, it'd be shiny and have that boss on it that would get hammered over. But this one was maybe hammered over by Westinghouse using this machine 100 years ago. We don't
Cool.
know.
Awesome. Very neat. That is really a neat piece. Yeah.
Now, what I have here is all the original construction books of all the Westinghouse steam-driven air compressors, back to 1894. I'm sure there were previous ones, but I don't have them. But there was all kinds of really neat information. One of them I was looking for in 1906 for a compressor, and across the page from it was some 11-inch compressors that were sent to the Norfolk Naval Shipyard. And it had the battleships that they were to go on in the engine rooms.
Oh, wow.
And they were part of Teddy Roosevelt's Great White Fleet.
Yeah.
So
So this is 1894, and on February 1st, there's a whole listing here of different serial numbers. It tells who they went to, Baldwin Locomotive Works, and so it's got the order number, it's got the size pump that went out. So it looks like Baldwin, they had a bunch in here to Baldwin, but a bunch of different companies and whatever in there. So if you got an old air compressor and want to find out, you say you'll look these up for folks?
oh sure, if you can find the original Westinghouse number,
Yeah.
which is usually on the center casting of the compressor, on the top or bottom flange. Although I found the numbers on top heads, I found it on the lower portion of the steam cylinder. And it's usually a 5-digit number, 6-digit toward the end there. And yeah, I'd be happy to look
Okay.
it up for people.
I'll tell you what, you got a Westinghouse air compressor over here, or an air compressor off of a locomotive. Let's go take a look at that so people that don't understand what one is, they'll understand what we're talking about.
Okay.
Yeah, let's go look at that.
All right. Well, this is a Westinghouse 9.5 compressor. It's a new one that we went through because it was an original that hadn't been used. But we completely rebuilt it, put new gaskets in, because the old gaskets, after 50 years of sitting in a crate, were not any good. But
So,
you know,
tell them this. Tell them what was this used for? Why was this important on a steam locomotive?
well, this was the steam-driven air compressor for the brakes on the locomotive and the train. So there was a reservoir or 2 reservoirs on the engine usually, and this would fill the reservoir. I've got a governor that goes with it that would automatically start and stop the compressor based on the air pressure in the reservoirs. So this is something that the engineer, all he had to do was watch the air gauge to make sure that everything was working right. The original ones by Westinghouse had a valve mechanism in the top head and a rope that the engineer had to use to reverse the compressor and make the thing work. But that was one of the first compressors done by Westinghouse in the I think his first one was 1868.
And how were brakes done before that?
It was just a steam jam brake on the engine. And it was a very dangerous thing. It's easy to design a machine to make speed. It's not so easy to stop hundreds of tons of
Yeah, well, before Westinghouse and its brake system, you had the brakemen that actually rode on the top of the box cars with the hand wheels and would run up and down and manually apply brakes on each individual car. When they went to the air brake system, the engineer could control the whole train from the cab of the locomotive.
An air brake probably sounds familiar because it's still being used today on semis and other locomotives. So for those that don't know, air pressure is what keeps the brake pads off. So for whatever reason, if this were to fail or a line were to bust, it would lose all air pressure and automatically go into what they call emergency these days and put the brakes on, and then you would have to fix the problem before you could keep going again. So
Yeah.
It's one of the greatest designs, probably saved as many lives as Edison did with the light bulb. Instead of using gas lamps, Westinghouse should probably get just as much credit, but it's not as much of a household name as it should be.
And if you ever really want to get into the history of Westinghouse, there's actually some really good YouTube videos up there just talking about the history of Westinghouse and all the stuff that he did, and really quite the inventor, and really revolutionized the safety of trains and in general back in the early days. And a lot of the technology is still in use today. So worth looking into if you want to delve into some history. This one you said you can operate it on air?
Yeah. So yeah, after we get done rebuilding it, we can run it on a 1/4-inch steam line at 130 psi shop air. When it's strapped on the side of a locomotive, it'll be 1.25 inch, 200 psi steam. So if we can run it on a 1/4 inch, that's how we know we've done a good job. And going through and completely rebuilding it. Now everything coming out here would be steam, the airline, but everything down here is it completely compressing air on its own, and in turn charging the brake system for the locomotive.
Awesome. And that's just one of the kinds of things you guys rebuild around here.
Yep, we've got dynamos that we can also show.
Okay. Yeah, well, let's finish doing the shop tour and we'll take a look at a dynamo.
Well, this is your standard Bridgeport. We've got a DRO on it, made life way easier coming into the 21st century, but it's pretty much a bulletproof machine from Bridgeport. Everybody pretty much knows who they are. It doesn't need much of an introduction, but
It's, yeah, well, a vertical mill is pretty much essential in any shop, and Bridgeport probably made more than anybody else. They're real common, great machines. Nothing wrong with a Bridgeport at all. So, yeah, you just got to have one.
a trusty mill.
Trusty mill.
This is our trusty Monarch, just a gearhead lathe. It's a model CK.
Yeah, CK.
It's got an actual swing of 14.5 inches, and before we got any CNC equipment in here, it's what made all the parts that drive a lot of steam appliances around America, and as far as out as we've got some customers in Australia, and we've done work for Disneyland Japan. It's a lot of it's come off this lathe.
This is a Pyle National K240 dynamo for steam-driven electrical generator. It's actually one designed for New Zealand and Australia with a removable portion for the governor valve. And this is the most common of the Pyle National turbines. 32 volt, 400 watt maximum, pretty much just to power the headlight, the tail light, and the cab lights in the steam engine.
So this basically just made the electrical power for lighting and stuff. So you think about a steam, modern diesel electrics making electricity. We didn't have electricity on the steam engine, so this is where they would power their headlights and stuff from.
Right.
And you said 30. What was the voltage?
32 volt
32 volts, which
DC.
is direct current. So that's kind of, it sounds odd today, but that was standard on locomotive stuff.
On every steam engine that was built up until the late 40s, when they started doing different voltages. 64 was another common voltage.
And you basically just had the steam piping into this, and that would spin that up and generate electricity, right?
Right. What you can't see in there is the turbine wheel that's attached to the shaft that turns everything here. And these buckets are special turbine bronze. And to be honest, I don't know what that composition is, but I have several miles of this stuff that you can still turn into new buckets. But this is the turbine. A larger version than would go in here, but it's the same principle.
So the steam would hit that and just spin it around. How fast do those things turn?
32 to 3,400 on the K240.
Okay.
So you got to really have these things balanced as well. When we're done rebuilding them, I send them out to a balancer that will spin balance these things. And they do a great job. It takes, you get a lot of vibration at speed.
I bet. And you got that one where you can run it on air too?
Yeah, this is how we test things here. Having a boiler to do all this adds a whole other level of complexity and cost. And I found that air works real well for our tests. So we haven't had any problems because of it. I generally set them a little bit lower on the governor, because steam will give me a little bit more in voltage than air.
Okay. And that one's hooked up to a little headlight, right?
Yep.
Let's spin her up and see it. See the light turning on. Thing's humming.
It's a nice unit. I mean, you can tell by the balance, there's hardly any vibration, and that's what you want. Otherwise, you just tear up your bearings.
And there goes the light. So y'all do air compressors, you do the dynamos. What else do y'all rebuild
Well,
here?
I've got all the original drawings for the air compressors and for the pile mashing dynamos, including some stuff for the sunbeams. These are little tiny, I think they are
That's a
Metropolitan.
Metropolitan, yeah.
Yep.
So, and the injectors, tell them what an injector's for in case they don't know.
The injector puts the water into the boiler. And there's a certain amount of voodoo in this.
That's a good way of putting it.
Well, you think about it, you have let's say you have a 200-pound boiler, and you're going to take that steam and put it through an injector, and it will pick up the water and force the water into the boiler. And you think it's a pressure situation, but no, it's got to do with taking the power of and expansion of the steam and transferring that to the water, and then that pressure that's generated lifts the check valve on the boiler check of the engine. So
yeah, if you think about how do you put fresh water in a boiler that's pressurized, you got to have more pressure than what's in the boiler, but yet we're going to use the pressure in the boiler to do it. So you actually have to through that injector, it basically, does a little voodoo and creates a higher pressure level to push that cold water into the boiler.
I wish I could think of the man's name who designed this, but he won the 1876 Paris Expositions Award for the newest invention of the year.
It was a game changer in the day.
A huge game changer, yeah. Because before then you had water pumps and you had to move the engine back and forth to put water in the boiler. And a lot of times sitting at a depot, that didn't work real well.
Right.
So, yeah. Some of the other appliances that we do, this is a real small 2-feed hydrostatic lubricator made by the Detroit company. And we get these things in and nobody's done anything to them in years. All the glasses need to be gone through, and the gaskets changed, new glasses, new gaskets. A lot of times the valve stems are bent, the feed nozzles are worn larger, and basically we have to go through them to get them back to a good working spec.
And tell them what a hydrostatic lubricator does.
This is a displacement lubricator. Basically, oil floats on water, and that's what this thing is doing. It uses steam from the boiler. It condenses the steam to water. You put oil in the chamber, and then the water comes in underneath. And as you use the oil, and it feeds through these feed nozzles that are here. What am I trying to say?
Well, I mean, basically what you're doing is on any of these steam appliances you need to have lubrication in them. So the way they do that, rather than having dripping oil, you actually inject or put the oil into the steam itself. And that will lubricate the cylinder in a piston, or it'll lubricate pretty much anything you have out here. So all your steam appliances or anything on the engine is going to have oil put in it. And this was basically how they put the oil into the steam in very simplified layman's terms.
Yeah.
And you could adjust the feed by turning these knobs down here. You could actually look through the sight glass and you can see a little drip of oil that will float up to the top, and you can adjust these on how much oil you want to put out, depending on what you're oiling.
There were usually small 15-watt bulbs behind the lubricator so that the dynamo could provide the power and for the light, and then you could see what your feed rate was through the glass. But these things are dangerous. They're under full boiler pressure, so you got to be careful. You can't just go throw something like this back on an engine without going through it first.
What else you got over here?
This is a safety valve for the boiler. The Consolidated Company made this particular valve, and it's one of the better ones for relieving the boiler pressure on a steam engine. There's a set pressure that each boiler is designed for, and if you get a higher pressure than it's designed for, it gets relieved through this valve. It sits on top of the steam dome on the engine, so when it goes, it will not harm anybody.
Right. You'd much rather the safety valve pop off than the boiler explode.
Yeah, right. But I happen to have a lot of the original. I made the original gauges to remachine the seats in these things, so that they operate properly.
And what's this other? What you got over here?
Well,
That's just
here,
a valve.
This is a governor for the
Oh,
air
okay.
compressor.
I got you.
And this is the Westinghouse A governor, A series. It was designed in the mid-30s to replace the original bronze-bodied ones, and it's a much more robust governor. But this will automatically, if it's set up properly, automatically regulate the amount of air that's in the air reservoir for the braking system on the locomotive.
So this is kind of neat. Bernie's got a pretty large collection of blueprints and drawings and stuff, and this is for a safety valve for a gauge,
For the
right?
gauge, for the machining gauge, for the seats and the safety valve.
So this is actually a gauge used for setting a safety valve. But what's really neat about this is this one was drawn specifically for the USS Arizona. It's got a date on here of 1916, and notice it was discarded in 1934 was when this became obsolete. But this was for setting the safety valve on the USS Arizona. And for those that don't know history, the Arizona is pretty famous in that it was one of the battleships sunk at Pearl Harbor on December 7th, 1941. So I guess those safety valves are still sitting at the bottom of Pearl Harbor right now.
We could rebuild them if they ever needed to. I doubt it.
That is a pretty neat piece of history, though. Well, guys, I think we're going to pretty much wrap this up. Had a good time here today visiting you guys and seeing what you do and some really cool stuff. And I tell you, a lot of this stuff is things that I've never really had the chance to get into or really the know-how to get into. So you guys are doing an awesome job with that. And let me ask you this. If anybody wants to get a hold of you, what's the best way to get a hold of you if they want to contact you for whatever?
Well, my email address is bernie@backshopenterprises.com. And phone number is 303-424-6882. I feel much better. My website is Backshop Enterprises.
Okay.
And I also just recently started a Facebook and Instagram page that'll cover the machining things, and we might get into some maintenance videos on what you should and shouldn't do to your appliances in the coming future. But yeah, check that out at
What's it under?
Backshop Enterprises
Okay.
on both Instagram and Facebook. Maybe someday a YouTube video, but we'll see.
Good deal. Well,
Thank you, Keith.
thank
Appreciate
you
it.
very much for your hospitality, and I appreciate the chance to come by and visit with you guys and get a chance to see some of this, and hopefully you guys will enjoy it as well. So with that, that's going to be a wrap. As always, thanks for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. And big huge thank you to the supporters of the site who support through Patreon and PayPal, etc. We couldn't do everything we do without your help as well. And with that, catch you on the next video. Again, thanks for watching.